Well, hey everyone, my name is Dr. Dan Grissom, and in this video tutorial, we're going to talk about the Stack Overflow error. So before we can actually talk about what a Stack Overflow error is, and what are the most common ways to fix it, we need to first make sure we understand what is the stack. So memory is divided into two major pieces that we typically consider when writing a program, the stack and the heap. Now, I'm not going to take a deep dive into the stack and the heap because it's not the purpose of this video. We're going to focus particularly on the Stack Overflow error, so we're going to just really talk about the stack and specifically how it grows. But I want to just kind of give you a very high-level picture of what the stack and the heap are, so you can have that understanding before we go into this discussion. Okay, so the stack is simply an area of memory, and it's implemented in RAM. Ultimately, this data is stored on your RAM, but we typically think of it as virtual memory. But the stack is implemented in memory, and it's used to store parameters and local variables. And I'll give an example of this in just a second so you can put a little meat to these bones, so to speak. Okay, the stack is divided into smaller portions called stack frames. And essentially, every time you make a new method call, you add a new stack frame to the stack. And then finally, stack frames are freed from memory when a method returns. So in Java, you'll typically see a return statement. Sometimes you're returning values if your method has a return type. If your method doesn't have a return type, if it's a void method, then you might not have a return, but ultimately that method will finish. And that is when the memory is removed from the stack. For that stack frame is removed from memory. Now the heap is very similar in that it's just a chunk of memory, but it is used to store objects. So anytime you use the keyword new in Java, so new array list or something like that, that data is actually being stored up in the heap. But there is a reference to that memory stored in the stack. Okay, and the data inside the heap can be accessed globally. So basically from any method, if you have a reference to that data, then you can access that piece of data from any method in your program. That's different from the stack, where basically you can only access that data from within the method in which it was defined. So this is our basic concept of scope. Objects in the heap, they're freed when the Java garbage collector basically concludes there are no remaining references to that object. Okay, now that is if you've never really thought about the stack versus the heap or what they are, that's probably not enough of a description to give you a really good picture of how the stack and the heap works. But I'm actually not trying to teach you that in this particular video lesson. We're specifically going to focus in on the stack, like I mentioned. So if you don't understand all that right now, that's okay. I think the next few slides will help you understand what I really want you to understand about the stack, so we can understand the Stack Overflow error. So let's take a look at a simple example. So, excuse me. On the left-hand side, I have some simple code. On the right side hand, I have a basic picture of memory. Okay, so I have a bunch of different rows of memory, and this is a 32-bit addressable memory to be specific. It doesn't really matter, but each row basically holds some piece of data. Let's assume that each row can hold an integer, which is a 32-bit value. So you can see each row has different addresses. This is hexadecimal addressing scheme, and I've shortened it. These are really would be much longer, but just for the sake of example, I've kept the addresses very small. So you can see address 00, 04, 08, 0C, and so on and so forth. Okay, and again, for what we're learning, you don't need to concern yourself with whether you understand this or not. It's just a kind of a technicality that is there. When we talk about memory, each memory row has a specific address. So here they are over here. Okay, the main thing I want to emphasize down here is the stack. Okay, so my memory is very large. Typically, maybe we'll think about having 4 gigabytes of address space in a program. So part of that address space is broken up into the stack, part of it's broken up into the heap, as well as there's probably some other small areas as well. But typically the stack and the heap is what we think of because that's where our program data resides. That is all of our variables. Okay, so the main thing that I want you to see is that, hey, the stack and the heap are two physically different pieces of our memory. And when we first start off a program, over here I have a simple program. It just starts off with a public static void main, and then you can see there's two other methods, a method A and a method B. Each of those methods has some parameters that get passed in, or at least one parameter, and they each create their own variables as well. So when we first start off a new program, the stack is basically very small. Okay, so when I first start to call the main method, you can see every main method in Java takes in this parameter strings. It's an arguments array list, or arguments array of strings. So these are parameters that can be passed in via the command line. So when I first call this method, essentially what happens is I have a reference to that argument on my stack, and you can see all it's really holding is an address. And this address is just some address up in the heap, okay? Because an array is an object. You can, when you initialize a new array, you use the new keyword. Okay, so that data for arguments, it sits up here in the stack somewhere, and it may take up multiple rows. And in this particular example, I don't really have any arguments, so I'm just kind of having it take up one row up here. Okay, but the main point is that as we go through this code, as we go to the next line, what you'll see is that when I create a variable, int main for instance, it belongs to this main method, right? We know if you've done Java for any amount of time, or really any coding language, you know that this int main is not going to be accessible anywhere outside of this method. Okay, and so what we see down here is as I went from the method header to the first line of code, you'll see that my stack and my stack frame both grew. Okay, and you can see my stack frame now has the parameter that was passed in, the args, as well as the variable that I just created. Okay, so as I go to the next method, or the next line of code, you'll see that actually spawns a new method. So I call method A. So what happens now is my main stack frame is kind of paused at this point. It's not growing. Now I'm going to be growing my method A stack frame. So you can see method A has this parameter A, which was basically a copy of int main. Int main got passed in as that parameter, and a copy gets made. So you can see on my stack I actually have two physically different rows that both are holding that value 0. Okay, so when we go to the next line of code, you see int A equals 1. I just created a new variable right there, and my method A stack frame grew a little bit. I go ahead and I call method B, so now I'm creating a new stack frame, method B. Okay, and as I continue on, you can see parameter B gets added to that method B stack frame, and again, that's just a copy of int A, since int A got passed in as that parameter. And as I continue, you'll see I create a new variable, int B, and then another one, int sum, which is just param B plus int B, which you can see is going to be 3. And then finally, I can print out the results of this, right? It's just going to print out 1 plus 2 equals 3. Okay. The main thing I want you to see here, okay, there's a lot of details on this. If you're brand new to the stack versus the frame, some of this might be confusing. But the main thing I want you to see, and I believe you can grasp at this point, is that as I run through this code, my stack is increasing. It's growing in essence, right? As I make more and more method calls, the amount of memory that this chunk of memory called the stack is consuming is increasing. Okay, now I should put a little asterisk here to say that there's other things that get put onto the stack. There's return addresses and whatnot. I'm just kind of focusing on the data to give you a very basic picture of this idea that, hey, as I basically am making more and more method calls, my stack frame is growing. If you have a method that has maybe 30 variables that are getting created, 30 local variables in method B, then my method B is going to get quite a bit bigger, right? My method B stack frame. And also that's going to grow the stack, because the stack is just the summation essentially of all the stack frames that exist. Okay, so the main point being here that as I call more and more methods, as I create more and more instance variables, my stack is going to grow in size. Okay, so let's talk about this Stack Overflow error now. Okay, so the main limitation that you need to be aware of is that the stack cannot grow infinitely. So typically you might find a standard stack size limit of about 1 megabyte. That can vary depending on how modern of a programming language you're using in terms of Java. or what operating system you're on, but think about a megabyte. Maybe it's a little less, maybe it's a few megabytes depending on your OS and what year you happen to be watching this video in. Okay, so a stack overflow error basically occurs when the stack runs out of space and memory. Okay, as this stack keeps growing, right, as you make more and more method calls, eventually you can run out of memory. Maybe you run into the heap, or you run into somewhere else, or you just run into that 1 megabyte memory limit that the stack is allowed to consume in memory. Okay, so this is what a stack overflow error really is. Okay, so there's two ways to fix a stack overflow error. As you can imagine, one is you could increase the stack size. Okay, but what I found, I've actually in 15 or 20 years of programming, I've literally never once had to increase the stack size. Not to say that you won't find a reason not to, but it's typically not the solution. You can technically do it using compiler flags and whatnot and things like that, but it's typically not necessary. Almost all the time, like I said, 100% of the time for me, and I would say probably 99% of the time for anyone who codes, 99.9%, Stack Overflow errors occur really because we have some broken code, quote unquote broken code. So the two most common causes of Stack Overflow error, and this is what we're going to take a look at in some simple coding examples, are recursion, when you have either a missing or a bad base case, or circular references. Okay, so again, those are the two common examples that we are going to look at. For me, I would say, if I wanted to break down all the Stack Overflow errors that I've ever seen in my lifetime, 99.99999% of them are from recursion. Okay, that may be a little bit of a result of the type of code that I write. I don't typically write code with circular references, but I imagine this definitely can happen in terms of circular references, so we're going to take a look at that as well. Okay, so let's go ahead and jump into some code and look at a simple example here. All right, so I want to write a recursive example to solve the factorial computation problem. Okay, so what is a factorial? If I had something like 5 factorial, okay, what does that equal? Okay, well, this is a very common mathematical symbol, right? If you're not familiar with or you don't remember what a factorial is, when you see that exclamation after a number, mathematically what it means is 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Okay, and in our example, if we pull up a calculator, for instance, we could see that 5 times 4, let's go ahead and run it in the calculator, 5 times 4 times 3 times 2 times 1 is equal to 120. Okay, so I'll go ahead and just write that answer down for us. Okay, well, essentially recursion, and again, this lesson is not on recursion, so I'm not going to go into a deep dive on recursion. I'm going to assume you kind of understand what recursion is. But if we wanted to solve this problem recursively, what we would do is we would say, all right, well, 5 factorial. I don't really know what that is, right? I don't know how to compute 5 factorial, so let me try to break this problem down. Well, 5 factorial is equal to 5 times 4 factorial, right? Because 4 factorial is 4 times 3 times 2 times 1. And then you could further break that down. You could say, all right, well, 4 factorial is equal to 4 times 3 times 2, or what we'd say, right, is 4 times 3 factorial if we were breaking this down recursively, right? And then 3 factorial is equal to 3 times 2 factorial, and so on and so forth. Okay, and essentially, if you think about this almost as a substitution, I could look at this and I would say, all right, well, 5 factorial. Well, 5 factorial is equal to 5 times 4 factorial. I don't know how to solve the factorial problem, but I do know that 4 factorial is equal to 4 times 3 factorial. So let me go ahead and replace that in there, right? 4 factorial is equal to 4 times 3 factorial. Well, I don't know how to compute 3 factorial, but I know it's equal to this. Right? So you keep doing that and breaking that down until eventually all you have is numbers, right? 5 times 4 times 3 times 2 times 1. Okay? So this is essentially what we're doing with this factorial problem. So let's go ahead and write some basic code for a recursive problem to solve this. So I'm going to go ahead and create just a factorial that I want to compute. So we'll start off and say we want to compute 5 factorial. Maybe I'll say fact equals 5. Okay, so I want to create a recursive method that returns some result. Recursive, and I'll call it recursive factorial, and it's just going to pass in that one parameter. Okay, so I'm going to pass in factorial, which is 5, and it should compute for me a result. And then I'm just going to print it out. So system.out.printf, and I will say %s factorial is equal to %, and I'll go ahead and format this a little bit with a comma D in case it's a very large number, and a new line. Okay, and then my arguments here are just going to be f and result. So essentially, let's go ahead and now create this method. I'll go ahead and let Eclipse create that for me. Okay, so there's my method. Private static long recursive factorial long factorial, and I'll go ahead and just make it f or something like that. Okay, so if I go ahead and just return 120, I could just hard code this. Let's just make sure that our code is really working here. I'm going to spell this. This should be fact. Okay, so if we run this, we see 5 factorial equals 120, right? But it's just hard coded. So if I put 55 factorial, it's still going to tell us 120, right? So what I want to do is I want to create my recursive case. Okay, so I'll come down here in my recursive method, and essentially what I want to do is I want to say return f times recursive factorial of f minus 1. Okay, that's essentially what we were doing. If we looked up here, we said 5 factorial is equal to 5 times 4 factorial before we ripped it apart, right? We said 5 factorial is equal to 5 times 4 factorial. So in general, we could say x factorial is equal to x times x minus 1 factorial. And that's exactly what we're doing, right? If you ask me to compute factorial of f, well, I'm going to tell you the answer is f times f minus 1 factorial. It's exactly what we see right here. Okay. However, what we'll see when we do this is we get what we were looking for, which is never what we're really looking for, the Stack Overflow error. Okay, so you can see this is typically what a Stack Overflow error looks like. You'll just see this mass of red text, and it's just typically the same thing over and over again, and it'll always point you to the same line of code, in this case 36. And what you always want to do is just scroll all the way up to the top, and you will see the official java.lang.StackOverflow Error. Okay, so the problem is I never actually stopped, right? I said 5 factorial, and then I started breaking that down. I said 5, 4, 3, 2, 1, but eventually I need to stop, right? Eventually I should stop at essentially 1 factorial. And I never did that, right? So every recursive case, if you know anything about recursion, you know that recursion must have a recursive case as well as a base case. So the number one time that you're going to see Stack Overflow error is when you're doing recursion and in this case, we forgot the base case. And in just a second, I'll show you an example where we had a base case, but we just didn't get quite the right base case, or we didn't get all the base cases. Okay, so I always like to open up the debugger for recursion, and you can see very clearly our call stack. Okay, the call stack is just those stack frames. So if we go ahead and jump into the debug mode, excuse me, in Eclipse, you'll see over here, I'm in debug mode, you'll see my call stack over here. Okay, now I'm going to go ahead and let me put a breakpoint out here. Okay, so I've got a breakpoint right here on my recursive factorial, and I'm going to go ahead and hit debug. Okay, so what you see here is I'm in main, and I'm just about to call recursive factorial. So actually, you can see over here my thread, my main. This is actually my call stack. This is literally you're going to see all the various stack frames that we had talked about back in our slides, where we had all these different stack frames. Okay, so if I jump down into this recursive factorial method, right, we come in with a parameter of 5. Okay, what we'll see is f is equal to 5, right? And then I'm going to call this one more time, right? I have 5 times whatever recursive factorial 4 is going to return. So I jump down into that method, and then you'll see now in the local context of recursive factorial, f is equal to 4. Okay, you can see on my call stack, I started at main, and then I made my first recursive factorial where f was 5, and then that called another recursive factorial where f was 4, and you can basically just keep diving, right? And it goes all the way down to f equals 1. You can see if you just watch the f value over here as I click through these different stack frames, you can see that it is indeed decreasing the further call that I get away from main. Okay, and eventually this is the point where something unique should happen, right? When I get down to 1, I should no longer be trying to break this problem down more recursively, right? But you can see I don't have any stopping point. I'm just unconditionally making more and more recursive calls. So what you'll see is I'm going to go down to f equals 0, -1, -2, and so on and so forth. Okay, so eventually we are going to, I could hold this down. You typically don't find it. You typically don't hit the end by just diving deeper and deeper. But the point I want to show you is here's my stack frame. You can see my stack frame is really, really growing. And if I just iterate up these, you can see I'm at -19, -41, -72, and so on and so forth. Okay, if you want to see how far we can go, you can always do something like just print out f. You can really see how far we get roughly. I guess it didn't quite we have the problem that we can't see it fast enough, but you can see it was in the 30,000s. You can see like I saw -5,000 if you kind of look very quickly. So it's getting pretty deep, right? It's getting pretty deep. Okay, so we need to fix this, right? So let's go ahead and we need to basically add a base case. So this is, again, the number one way to fix a Stack Overflow error is make sure that you have a base case. So maybe you say something like this. All right, well, if f is equal to 1, then I want to return 1. Okay, else, then I'll go ahead and compute, I'll go ahead and dive deeply. All right, so basically if I go down to this level right here, right, where I'm really trying to compute 1 factorial, okay, I don't want to return 1 times 0 factorial, right? I just want to say, hey, 1 factorial is actually 1. That's a definition of factorial. Okay, so if f is equal to 1, then return 1. Okay, so let's go ahead now and play this, and we will see 5 factorial is equal to 120. If I go ahead and I make it 6, then you'll see we get 720. So 6 times 120 is indeed 720. Okay, so it seems to be working. And again, this is actually typically where people get into trouble with Stack Overflows, the Stack Overflow errors, because they set up recursive and they set up a base case and it appears to be working properly. But if they test out their code a little bit more, maybe they do something like 0. And oh shoot, a Stack Overflow error. Okay, so essentially what we found out was there's actually a case that we didn't cover. Now it turns out for the factorial problem, by the definition, if you go onto Wikipedia, you'll find that by the definition of factorial, 1 factorial is equal to 1, but we also have that 0 factorial is equal to 1 as well. So you might want to go ahead and say, or f is equal to 0. Okay, so that way I can compute 0 factorial is equal to 1. I can compute 1 factorial is equal to 1. I can compute 5 factorial is equal to 120. I can compute 20 factorial is equal to some very, very large number. Okay, and you're feeling pretty good again, right? But then you know your user does one more thing and they say, well, what's -3 factorial? Okay, well that case wasn't covered, right? I'm basically assuming with my recursion here that I'm counting down. So you might need to add one more case here. If f is less than 0, right, then essentially I just want to print out maybe a system.out.print cannot compute a negative factorial. Okay, and I'll go ahead and just return, since I need to return something, -1. Okay, so cannot compute a negative factorial. You could see -3 factorial because it's -1. I would obviously want to reprogram my output up here to maybe say, hey, don't even try to print this. Okay, but all that to say, the number one case you're going to see when you get that Stack Overflow error, it's gonna look like all that red text popping up on the screen. Is you want to first look and see what line of code that it was displaying the error on, right? If I just comment out all this code, it'll always tell you where the problem is. You just say, all right, line 44. Oh, I have a problem with my recursive factorial method. It doesn't have the base cases set up properly. Okay, so again, anytime you see this huge chain of something over and over again, you can confirm it's a Stack Overflow error. Go to the line of code, and then that will basically tell you almost with certainty that you need to go ahead and you need to examine your base cases more thoroughly for that particular recursive call. Okay, so that's the first type of Stack Overflow error that you're going to see. And again, I would say that's 90% or more of the Stack Overflow errors you're going to see. But you also may see another error related to circular references. So I'm going to show you an example by creating two very simple classes, a father and a son class. Okay, so the idea behind these classes are that I create a father class, just has a first and a last name, and it has a son, right? A father has a son. Likewise, a son has a father. So I might have this type of relationship modeled in my class. So I'm actually going to go, typically you should create a new class in its own file. For the sake of just simplicity, I'm going to keep my class definitions all in one file. Okay, so I'm going to go ahead at the bottom and I'm going to create a father class. Okay, so my father class, this is going to be very simple. I'm just going to say class father. Okay, and it's going to have basically instance variables, and it's going to have a default constructor. Okay, so I might go ahead and create a private string first name, a private string last name. Okay, and let me go ahead and create a constructor. So public father, and it's simply going to set the first name equal to Joe, and it's going to set the last name equal to Smith. Okay, and then maybe I'll do one more thing. I'll do a toString method. Okay, so I'll say public string toString, and this is simply going to print out something like this. Father is named, I'll do a printf here, so printf, father is named %s, %s. First name, last name. Okay. All right, so, sorry, I need to return, not print that. String.format, there we go. All right, so let's go ahead and just test this class out very quickly. I have a father, just has two instance variables, a default constructor that initializes the father to Joe Smith, and then a toString method. Okay, so if we come up here and we just say father is equal to new father, okay, you can see that should compile just fine. And then I can simply say system.out.print father. And what we get is father is named Joe Smith. Perfect. Okay, so let's go ahead now and say, all right, well, I like that class. I'm going to go ahead and create a son class. And for starters, it's going to be very similar. So I'm just going to copy copy and paste it, and I'm going to change father here to son. Change my default constructor to a son instead of a father. I'll give him a name of Joey Smith instead. And then here, son is named first name, last name. Okay, so I can create a father and a son, and then obviously I could go ahead and print those out as well. Okay, so I have these two classes, father and son. For now, they seem pretty redundant, right? But what I want to do now is I want to add this relationship, right, to show that, hey, a father is actually related to a son. A father has a son. So in a default constructor, I might do something like this, right, where I say, all right, well, I also want my father not only to have a first name and a last name, but I want them to have a son as well. So I might go ahead and add a new instance variable here. For son, now that we have that son class, so son is equal to new, or I'm sorry, we'll just kind of declare it right now. So private son. Okay, and then my default constructor, I would say something like this: son is equal to new son. Right? And likewise, in my son class, I should have a private father. Okay, and then I would go ahead and I would say, all right, well, father, I'm going to initialize to a new father. Okay, and let's go ahead and run this, right? The idea seems to make sense. I have my, go ahead and delete this so it's kind of out of our way here. I have, I want to create a new father, and that father should automatically create a son. Likewise, right, if I wanted to create a new son, then that son needs to have a father. Okay, so when we run this, what we see is this, again, this huge chunk of red and blue in Eclipse. It has the links. And if you scroll all the way up to the top, you'll see java.lang.StackOverflowError. Okay, the only difference between this and the last example is each line is not the same. Okay, in the past it was the same recursive call over and over again, but now we see we're jumping back and forth between father and son. Okay, and so you can see it's line 52 and line 74. It's basically showing us which lines are causing the problem. So that's always the strategy that you want to use when you see that Stack Overflow error. Go and click on the line that it's referencing and go see which line of code is causing that, because what that's telling you is we have a problem here. Okay, now I'm going to go ahead, and it's always a good idea whenever you see a Stack Overflow error, almost always the thing that you want to do is jump into the debugger. Okay, so I'm going to go ahead and set a breakpoint on my inside my constructors here, and I'm going to set a breakpoint also at the very first constructor call. Okay, so let's go ahead and jump into the debugger. Okay, so you can see right here I have father equals new father. So I'm about to initialize a father. So let's go ahead and dive down into that method. And you will see now on my stack I have main, right? So we started in the main at line 23, and that took us down into the father constructor. Okay, so if we go through this, you'll see I initialize on my father, just as I would imagine, Joe and Smith. And then I go and I say, all right, well, cool, I'm making a new father. I should go ahead and create a new son along with it. Okay, so I go down and I create a new son. And I go and start to create Joey, good old Joey, all right? So Joey Smith, okay? But what we see here is that the son is actually trying to create a new father, which actually doesn't quite make sense, right? Because we already have a father in existence. We need to, the son should have the same father instead of the son trying to create a second father. And this is where we have the problem. So you can get behavior like this kind of bounce back method. So what this is going to do is it's going to go ahead and try to create a new father, a new Joe Smith. And then that second father is going to try to create a second son. That second son is going to try to create a third father, a third father, a third son, the third son, a fourth father, and so on and so forth. Okay, so this is just going to go on and on and on until we run out of memory in our stack and we get that Stack Overflow error. So you can see if I click on each of these IDs are going to change. Right? We should just have one son and one father, which means every father that we see should have the same ID. It's basically an address reference. But what you see instead is as we click on all the different father stack frames, you're going to see ID 63, ID 61, 59, 57, and so on and so forth. Same things with the son, right? All I really wanted to do was create a father, which should create a single son, right? But the father is creating a son is creating a father, and so on and so forth. Okay, so these circular references, right? This is a circular reference because the father is referencing the son is then referencing back the father code, the father is referencing the son, and so on and so forth. And we get this huge, never-ending circular reference chain, which causes that stack overflow because eventually, like you saw in the debug mode, we're just going to keep adding stack frames. All right, so in this particular case, I can fix this quite easily, but I need to add, in my case, a new constructor. So what I'm going to do is I'm actually going to basically notice that, hey, if I have created a father, I don't want to create a son that's going to create a new father. I want to create a son that basically knows who his father is. Okay, so what I'm actually going to do to fix this is I'm going to copy my constructor down here, and I'm going to make a new version, an overloaded version of this constructor. And this overloaded constructor takes in a father. Let's say param father. Okay, and instead of creating a new father, that son says, oh, I already have a father. I know who it is. My father already exists, right? Okay, so we just pass it in. And then that way, when we call this father constructor, we always just want to say, hey, I already exist as a father. If I'm creating a new son, if I'm having a new son, that son should not create its own father. It should simply pass in this father. Okay, so now what I'll see if I run this, I get father's name Joe Smith, and I can go ahead now and update my toString if I want. Father's name Joe Smith. His son is %s, and I can go ahead and pass in son right there. All right, so father's Joe Smith. His son is named Joey Smith. Okay, so the verbiage there is a little bit off, but you can see very clearly that we have Joe Smith and Joey Smith. So likewise, in my son, if for some reason, now it makes sense logically that I'm always going to create the father and then the son comes out of the father. But if for some reason I wanted to do this the opposite way, right? Son is equal to new son, and then I do a system.out.println son, I'm going to have this same problem on my son, right? Well, son is named Joey Smith. We need to go ahead and fix this code. So let's go ahead and do the same thing for the son, okay, that we did for the father. So essentially what we're going to do is we're going to come up to the father class and we're going to make an overloaded constructor. Okay, and this overloaded constructor is going to take a son, param son into it. Okay, and it's just going to set son equal to param son. Okay, and then in my son class, I need to make sure that if they call the son, then essentially I want to pass in this son to the new father. Okay, and then finally we can go ahead and update our toString method. So son is named, his father is %s father. Oops. Okay, and what we see here, this is actually another great example of a Stack Overflow error that we get with circular references. The first circular reference we had was from the constructors, but what we're seeing here is actually a circular reference from our, if you notice, where are all the errors? Lines 67 and 96. If we go to 67, we see that the error is actually in the toString method. Okay, and then 96 is the toString method as well. So what you may not realize when you do something like this is son is actually calling son.toString. It's kind of implicit there. father is calling .toString. Okay, and so what happens if we jump into the debug mode? I'll go ahead and run to my first print method. Got a little caught up here. Sometimes it's a common problem with Stack Overflow because it's taking up all your memory. It can cause your runtime to freeze because it gets going in that huge stack dependency. So I'll wait for this to free up, and we'll jump back in. Okay, so we'll try this again. So this time when I hit the debug, I'm going to now try to print father. Okay, so what does that do? Well, it goes down into the father's toString statement. Okay, but what's that doing? Okay, well that is itself calling son.toString. Okay, so we go down into the son.toString. Well, what's that doing? It's calling father.toString. So basically it's just trying to return this string over and over and over again. Okay, so we have again this circular reference where we're jumping back and forth. You can see father.toString, son.toString, father.toString, son.toString, and so on and so forth. So it's just something you have to be careful with whenever you have these one class contains another class types of relationships. You're going to get more of these circular references than you imagine. So in this case, probably what I would do, just to make this a little bit easier, not have to do getters and setters, I'm going to make these public in terms of these instance variables. Now, you would typically want to do a getter and a setter, but for the sake of time and not making you code more code than you need to, his son is %s. Okay, so then I can say son dot first name, son dot last name. Okay, likewise down here, %s, and then father dot first name, father dot last name. Okay, and then when we run, we see father is named Joe Smith, his son is Joey Smith, son is named Joey Smith, his father is Joe Smith. Okay, so in this video tutorial, we took a look at the Stack Overflow error. Okay, and we specifically talked about what is the stack and what is a Stack Overflow error. It basically occurs when the stack increases so much that there is no more memory to contain all of the stack frames, and that almost always happens with recursion when I have a bad base case. The second time that typically occurs, like the second most frequent occurrence of the Stack Overflow error, is having circular dependencies and circular references like we saw with this father-son class. We first showed an example where we had that in the constructors, where the constructors were trying to construct one another infinitely. And then we saw it in the toString class, where the one toString, we thought we would be clever and just reuse the toString of the son or the father, but we saw that created a circular dependency. So it turned out that it was better for us to pull off, just avoid making that call to the other class, and just pull out the pieces of information that you need. And essentially this was not quite recursion, because we had the toString was calling toString before, but it was calling a different class's toString. So that type of behavior was recursive like, but not quite recursive because it was technically two different classes. As a general strategy for solving Stack Overflow errors, you'll know a Stack Overflow error when you see that huge massive red text that's just the same thing over and over again. And obviously you scroll up to the top and see that Stack Overflow error. Really the way to solve it is just to look at what line of code that it's pointing to, and that's almost always going to point you to the recursive call that you need to go and shore up those base cases, or it's going to show you the circular references that you were making back and forth. All right, so I hope you enjoyed this video. If you did, be sure to smash that like button and subscribe to the channel. We've got some really cool stuff coming up. Thanks.